Okay, Year 8. Welcome to your tutorial on working with problems involving indices. So far we've looked at how to multiply, how to divide. Today we're going to look at questions that involve multiple steps involving indices. So what are we looking at? Sometimes we're given questions that require us to combine our knowledge of a range of different topics, okay? You'd be used to that because you get those kind of questions in tests a lot. Today we're going to look at solving algebraic problems with indices that involve multiple steps. So like I've said, we've looked at multiplying and dividing with indices. Today we're going to look at problems that have multiple steps within them. So let's look at this one here. It says 6x to the power of 6 times 2x divided by 3x to the power of 5. Now, when I look at this one here, I've got 6x to the power of 6 times 2x. Okay, I'm going to do that multiplication first. So 6x to the power of 6 times 2x. Let's deal with this bit first. Now, 6x to the power of 6 times 2x. Let's deal with my numbers first. 6 times 2 is 12. Okay, and I've got x to the power of 6. Well, I'll do it in a different colour. Let's get it green out. Okay, now I've got x to the power of 6 times x. And I remember when I have a pronumeral, I put a little 1 there. Okay, I put a little 1 there. So I know that when I'm adding, I go 6 plus 1 becomes 12 to the power of 7. Okay, because all I've done is I've added my indices, okay, with multiplication. Now I've got 12x to the power of 7 divided by 3x to the power of 5. So let's rewrite this up here because now I'm doing division. 12x to the power of 7 divided by 3x to the power of 5. Okay, pretty straightforward. So let's have a look at what I can do here. So 12x to the power of 7 divided by 3x to the power of 5. Let's deal with my numbers first before my pronumerals. 12 divided by 3 is 4. Okay, x to the power of 7, x to the power of 5. So it's got 5 on the bottom. 7 subtract 5 becomes 2. Okay, so it's like I've got 7 x's on the top and 5 x's on the bottom. I cross out 1 for 1. Okay, that would leave me with 2 on the top. So my answer for this one becomes 4x to the power of 2. So you'll notice there that we couldn't just do that in one easy step. I had this bit to do the first and then all of that divided by that one there. Okay, that involves multiple steps. So it's a matter of just sitting back and saying, okay, which one goes first? This one here, okay, this one here is a little bit different. I've got 10 a to the power of 6 c to the power of 2 plus 2 a to the power of 2 times 6 a to the power of 4 c to the power of 2. Now, holy moly, what can I do? Okay, now I can't group these two at the moment because they're not like terms. Okay, they're not like terms. So I can't really do too much of this at the moment. So let's see what I can do. What can I do? Oh, okay. I can do a squared times 6a to the power of 4 c to the power of 2. Okay, so let's have a look at doing this little bit first. Okay, a to the power of 2 times 6a to the power of 4 c to the power of 2. Oh God, that looks really complicated. It's actually not. I've got this a in here and I've got that a in there. I can leave everything else the same. So I can leave 6 c to the power of 2 the same. Okay, and I've got a to the power of 2 times a to the power of 4. I remember my rule tells me all I need to do is add my indices. So a to the power of 2, a to the power of 4 becomes a to the power of 6. Now you'll notice as soon as I've done a to the power of 6, it becomes a like term with this one, a to the power of 6, c to the power of 2, because with addition, I can only combine like terms. Okay, and as soon as I've done this multiplication, these become like terms. So 10a to the power of 6, c to the power of 2, plus 6a to the power of 6, c to the power of 2, a is to the power of 6, c is to the power of 2, which means they're exactly like terms, so it becomes 16a to the power of 6, c to the power of 2. Why have I left that a and c the same? Because we only add our indices when we multiply and we divide, okay? Because we are doing addition here, it's only grouping like terms, and because these are absolutely identical like terms, I can group them and get this answer, 16a to the power of 6, c to the power of 2. Okay, what have I got here now? I've got 4p to the power of 5 divided by p to the power of 4 times 6p. Okay, let's do this multiplication on the bottom first because I can't actually divide until I've worked that out. P to the power of 4 times 6p, okay? Now, let's deal with my numbers first. I've got a 6, and I can assume I have a 1 there. So 6 times 1 just becomes 6, okay? P to the power of 4 times, you'll notice again, I put that 1 above that p, so I know when I'm adding, I have to add a 1. P to the power of 4, p to the power of 1 becomes 4 plus 1 is 5, 6p to the power of 5, okay? So, let's rewrite this. 4p to the power of 5 divided by 6p to the power of 5. Okay, my p to the power of 5s cancel each other out, and I'm left with 4/6. Now, is my answer totally correct? It's right, but it's not simplified in its most simple form. 4 to the power of 4 divided by 6 can actually be written in a more simple way. There's a number that goes into 4 that also goes into 6. There's factors of 4, 1, 2, 4, 4 doesn't go in, okay, so it's going to be 2. 2 goes into 4 twice and goes into 6 3 times. So my answer for this question here becomes 2/3. And that's it, guys. That's working with multiple steps in solving algebraic indice problems.